So good morning. We have a lot to cover. As I was going over this, I was thinking, really, soils? Maybe I've outgrown this. You know, I have my PhD in soils, but really, is this just going to bore people to tears? But if you look at this, and I don't know if you can see if the colors are better. Should we turn the lights down?
Yeah, that would be great.
Is that better?
Yeah. Wow.
Okay. So one thing you can tell a lot about soils. There's a book called Soil Color. Just briefly, I will say we can't really tell which ones of these are sandy, but we can tell the ones that are clay. The red ones are clays for sure. The yellow ones are probably clays. And we can tell that this one is has been exposed to less water than this one, and this one has been exposed to less water than this one. And what do you think about the gray one? If it's gray and it's clay, what do we know about that soil?
It's not very fertile.
Well, she's saying it's not very fertile and that in general, our clays don't have a ton of fertility. So that's true. What else do we know about the gray clay?
It's pretty dry.
It's what?
Would it be very dry?
It's actually the opposite.
Really?
Yes.
Oh, wow.
Gray clays have been wet for, they've been not necessarily submerged, but they've very poorly drained areas, maybe compacted, they've stayed wet. And what's happened is the iron, our soils are full of iron, these clay soils, that's what makes them red and orange. When they're exposed to a lot of water, they get oxidized and so they turn gray. So if somebody calls you and says, yeah, I've got this hard clay soil, you can say, well, give me, what color is it? If they say, well, it's gray, you're like, buddy, you're gonna have to deal with drainage. We know. That's just one of those few things you can know. Gray clay is poorly drained. Okay, so soil is kind of our basis of life, blah, blah, blah. What I'm gonna talk about today is our southern soils, kind of just a real brief history of place or sense of place, context. Zero down a little bit on sand, silt, clay, organic matter, some of their characteristics, why they're so important, how they behave, some options of composting and mulching. Okay, as I mentioned, I love artistic things. This is from a Back to Earth hippie conference I went 2 years ago where I took a bunch of soil samples and they created that. These are all North Carolina samples.
Wow. I mean, you created those?
I did not, the group did.
Wow.
We, it's like I said, it was one of those hippie groups. Everybody's involved. But look at that. I mean, that's our soil. It's just so beautiful to me. So our southern soils, we all know we have the mountains, the Piedmont, and the coastal plain. What a lot of people may not know, though, is 250 million years ago, when the continents were connected, this part of our state and the southeast were connected to northern Africa and Europe on the northern part of it. And when they split apart, these mountains are actually the same material that is in the northern part of Africa and in parts of Europe.
Wow.
Our mountains have never been covered by glacial material. They've never, in the 250 million years since we separated out, became North America, those mountains have been exposed to the sky and the weather. So that's quite different than other parts of the country. In New England, upper Midwest, California, they've had glaciers, many glaciers, 1,000 foot deep, grinding their soils. Consequently, they have topsoils that may be, that are generally measured in yards. Ours are measured in inches, our topsoil in this state, because they're all eroded material from our old Appalachian mountains, comes down through our Piedmont, some down through the river basins to our coastal plain. So we can say that most of the soils in our Piedmont area, certainly in Wake County, are eroded materials from the old mountain ranges. The coastal plain has been covered by the ocean maybe 16 or so times. I don't know about beachfront property people because history tells us that over millions of years, this will probably happen again. But we have some wetland soils here, peaty soils, but for the most part, we have very sandy soils here with calcium deposits from the ocean. That doesn't make the pH high, it just makes it sandy. So contextually, our soils are derived from eroded old mountains and ocean deposits. We live in a very high heat, high rainfall area, which causes nutrients to leach, and it really speeds organic matter breakdown. There's, I can't think of the exact rule, it's called the 10-degree rule, but every time the temperature goes up 10 degrees, there's like the increase in chemical reactions, like it goes up exponentially or something. I don't know. If anybody can help me on this, help me. It goes up huge. The number of microorganisms that grow, the breakdown, the mineralization of rock, all these things happen much, much faster under high heat. So think about it. We're in the South. We've got old hills. We got a lot of heat, and we also have moisture. So when you think about this, this is going to define, or this is the background for the decisions you're helping people to make in regards to fertilizer, in regards to how often they apply compost, you know, and of course soil testing, which supports all that. This is our world. We live in a hot and wet world, folks. So it's very different when you have the people from New England come down here and, what do you do with these soils? You know, they can complain all they want because our big bonus down here, we may have poor soils. We may have to add stuff to them. But gosh, how about our seasons? We have these beautiful long seasons. We can garden, you know, they get 3 months. So we typically have to add lime and nutrients and organic matter. And this question of how much to add is our real ongoing work that we want to understand better. Okay, thin top layer. We don't have glacial soils here. We are not cool and dry. If it's cool and dry, that organic matter piles up. So when you see soil test reports from New England, they may have 5 or 6 or 7% organic matter. We will never have that. I have been the most organic gardener you'd ever want to know. I never got mine above 1.5%. So different world. It's a different world. Okay. The other thing, excuse me, in our area is that almost none of the soils that you talk about with your clients are really natural soils. Most all of them are disturbed. So, you know, we can talk about soil series all day long, but really what you're doing is you're asking them, what's it like now? Is it draining? What color is it? You know, what do you want to do there? Blah, blah, blah. So you're not dealing with anything that's natural here in Wake County for the most part. Okay, so in summary, created from old mountains, hot and moist, and our soils are disturbed. So that's one of your filters as you're talking to people. We're gonna recognize that these are the facts and go from there. And between each of my sections, I'm gonna have a beautiful picture, just so you'll know we're transitioning. That's a transition for little kids. We do that. Okay, we're gonna be leaving soon for the. Okay, so the next section is sand, silt, clay, and organic matter. Yeah, so we see this diagram a lot. They say 50-50 should be air and water. We have our mineral matter, which is sand, silt, and clays. And then we have organic matter. Now, organic matter is not really this big of a slot. It's really this tiny little piece, but I couldn't get OM in there, so I had to make my pie bigger. And then sometimes you'll hear about soilless medium. And what this is some soil they've created oftentimes from just organic matter and like bark chips or something, and perlite or vermiculite or something like that. Generally, it doesn't have this mineral matter in it. So just so you'll know what soilless media is, they use that for starting plants or in tree nurseries and things like that. You know, this is I'm sorry, this isn't clear. It looks old fashioned and everything too. You all can see, right? The main point in this is that the surface area, now think surface area is the outside of something, you know, that's the surface area. It's not how much it weighs or anything, it's just the surface. The surface area of a particle of sand is about, let's just say 11 gram, should be cubic centimeters per gram.
No, square because it's a surface.
Well, it says square, but I'm thinking, anyway, it's 11 compared to 8 million for clay. I mean, just think about that. You know, and I bring this because, you know, there's a piece of sand. You get a piece of sand in your eye and you feel it.
Mm-hmm.
One piece of sand. And you can see the outside of it. It's solid. Clay is so tiny you can't even see it with your eye. You cannot see a particle of clay with your eye. It's also flat as a pancake and it piles up like this. So completely different. So think about the surface area. You got the surface area, this piece, this piece, this piece. There's tons of it inside, outside, top, bottom, you know. The surface area is just so much more than this piece of sand. And then you've got organic matter, which we'll talk about in a minute, but it's got surface area beyond this, and it's like a sponge too. So this is important, I think, to never forget. We are dealing with two different creatures here when we talk about clay and sand. And basically, I like to forget about silt. Nobody has ever said, I got a silty soil. Can you tell me how to deal with this? They exist. Of course they do. But people will either say sand or clay. The important thing here that I don't think people really talk about much, it's like a secret, or they just, anyway, different parent material. Clay comes from a completely different parent material than sand. This is why they're different. This is why one is like this platy structure with a lot of surface area. And this one is just like a chunk of crystal. It's like those crystals you buy to cleanse yourself or whatever. You know, it's crystalline in nature. So very different parent material. And silt is just a very tiny piece of sand. So it has more of the characteristics of the sand than it does clay. So different chemistries, different physical behavior. They are, you know, clay is slippery. Clay can be made into pottery. You can't make pottery out of sand. Completely different. And here's why infertility is so important. You see this very platy structure. It's got all these cations on it, calcium, magnesium, potassium, you know, all these nutrients. And it's got these little negatively charged sites where different silicas and aluminums and things have been on that have leached off, and it can hold these nutrients. So sand, I mean, you can just look at this sand and say, wow, there is no way this particle is going to be able to do what this one does chemically in terms of holding on to nutrients. So when we're talking to people, we're finding out, do they have sandy soils? Does it drain really fast? Does it drain slow? Do they think it's clay? It's going to impact their nutrient needs. So cation exchange capacity, there's not a ton you need to know about that. Nobody's ever going to ask you about it. But it helps you understand that clay does have a much better capacity for holding on to cations. So here's just kind of the same repeat. That's an electron microscope. that's magnified way more than this. So clay has moderate to high cation exchange capacity, sand has low. Okay, any questions on that? Because that's kind of basic to, okay. Now, we're going to talk about organic matter. Oh, gosh, that was, I'll remember that. Don't repeat that. Okay, so organic matter is kind of everything. So the hippies were right. Okay, y'all don't even remember the hippies talking about everything organic. Everything had to be organic matter. They only added more organic matter, but it really is true, especially in our southern soils. Remember, they're clay, they're low in nutrients. We have a lot of water, but we also have a lot of droughty periods here. So organic matter supports all of this. It holds nutrients, moisture, and it forms a glue, which we'll talk about in a minute. And as I mentioned, organic matter in the South is typically very low. On the soil reports, they report humic matter, which is just approximately, it's rough approximation, about half of total organic matter. So anytime you look at a soil report and you see the humic matter, you can double that and say, well, that's about how much organic matter there is. It's not much. And the reason that organic matter is so important is it's all got, every bit of it has a carbon, which forms these bonds with hydrogen, and they can drop off and they can attach to other things. So that's why organic matter is so important. It's got this ability to form all these connections with a wide variety of nutrients. It's so complex. I once asked a professor, why don't people know more about organic matter? Why don't, there aren't more studies about it? He said, it's so complex that nobody wants to dig into it. And it's different here than there. So just know that it's extremely diverse in all ways, but it has an extremely high CEC. Just think about this. Not only like the platy clay, but it has layers and different materials that can all absorb and hold on to nutrients. So lots of nutrient holding capacity. It's one of the reasons we love it. And this is just a picture, excuse me, of a clay particle, humus particle. We don't have sand here, but it just shows some of the movement. Here are all these cations, and they're the hydrogen ions that get kicked off when you add lime. And then that makes room for these to move over there. So that's why we add lime to our soils. They forget they don't include the microbes here, which is unfortunate because really microbes are doing most of this transfer work. It's not just in soil solution. I'm not a big hydroponics fan myself. To me, that seems like you're missing out on everything the earth has to give you. See, I'm kind of woo-woo. But hydroponics will work. You can put it in nutrients into solution and you can grow things, but there's a lot that it doesn't take into account. Okay, so organic matter impacts the soil structure, and this is huge. This is really one of the biggest reasons we love it. So you have a sand grain, then you'll have 5 sand grains, and it will clump those together. And clay, of course, it's combining billions. But, as it breaks down, it's providing this glue to hold it together. So structure. This is the structure. Things clump together with pores. That's structure. So texture is just the percent of each of these in there. Structure is all about how they're grouped and how well they perform together. And you see that the green is the organic matter. So this looks like kind of a funky slide. Can everybody see it? It's a little bit squirrely, but I think it's good to know that most of the organic matter that we have in our soils may have been there thousands of years, and it's in a state of stabilization. It's no longer chemically reactive. You can't break it down. Microbes can't break it down. It's moved into a state of complete inertness. It can help with moisture, it can stickiness, but it's not going to chemically provide nutrients. And then this is why we need to apply fresh material in order to get nutrients. So we'll get some benefit from this older material, but this is why we want to support living organisms. We want to add, keep growing things on our soil, like roots, keep microorganisms alive. Roots die and they produce organic matter. So living things can help. And we also add decomposing materials because they're freshly dropping food. They're dropping food for the microbes, they're dropping food for other plants. But just know there is this background that is not, this is why we have to add it fresh, is it will eventually move into this unavailable form. Don't ever underestimate the importance of microbes in taking the food from the compost, mineralizing organic matter, and moving it to the plants, making it available to the plants. They are critical. It's not just a passive dump in fertilizer, boom, it all gets taken up. Most nutrients get processed through microbes. Some get processed very fast, some are water soluble, but a lot of the work gets done by these guys. So our goal is to keep them alive and keep them happy. And that's just easy because it's what plants like. They need some food, they need oxygen, and they need water, damp but not soggy. Now here's the point. What if you have an intense mulch, for instance, like 1 inch is good, 5 inches is better. What's happening under that 5 inches of mulch? Are you getting any oxygen? No, you won't get any oxygen, and it'll stay soggy. These guys will not flourish, or you'll get a different group of these guys, and they may not be the ones that are particularly helpful. So really just think about, you want an active system, you want them constantly breaking the stuff down, but you don't want to make them uncomfortable. This actually, I had to take these pictures because I couldn't even believe it myself. This was a new garden. I went out one day and I had dug it up real deep, double dug it because it was rock hard clay, added a whole bunch of organic matter. And a few months later, I went out and took this picture. You can see there's still bits of organic matter. Some of it's incorporated. I can hold a whole piece in my hand like this. I walked the same day over to my older garden and there was the soil. Now you can really see the difference, completely different soils. So what has happened there? The organic matter is broken down. What else?
Well drained.
It's well drained. It's crumbly. Why is it crumbly? Because it's got the glue. It's got the glue, that's the organic matter that has taken that clay and bit by bit covered small little beds of soil. I tell people this takes about 3 years. You're not going to go in, no matter what quality compost you add, you're not going to get this for a while. It's going to take a while. And same thing here. So yeah, it takes about 3 years. And unfortunately, we often get our best crops in the first 2 or 3 years because disease and nematodes and things like that haven't set in yet. It's really kind of one of those ways nature tells us to lighten up, who's in control here, right? Because the more we garden in an area, sometimes the more disease problems we have, but that's for the pathologist to talk about, not for me.
So how did you mix that? Was it tilled in? Was it raked in with the clay?
Well, you can do it a number of ways. For me in that garden, I dug it up because it was hard clay and just mixed in the compost, to whatever level I could. The thing is, it really takes the microbes, breaking it down to coat the beds. So you can mix it in all you want, and it may look nice and brown, but you're not going to get the full benefits until it's had some time to kind of ripen and mature, like a good wine or something.
So the subsequent year, did you just like top dress it with the?
Yeah, that's a good question. That is really a question that people will ask. Okay, how do I follow up? So it's a bigger question. You got to sit with the person. What do you want? What kind of garden is it? How much maintenance do you want to do? Is it an established perennial bed or is it a vegetable garden? These will all play into that decision. In general, as we see down the line here, you can, in subsequent years, if you get your soil figured out, lime, fertilizer, get it, good compost in there, you shouldn't have to dig it up in subsequent years. You should be able to work on it from the top. And we'll get to that a little bit more, but you should not have to. We're doing this just to help with the tilth and the looseness. The ongoing nutrient management will come later, and it can come more from the surface if we get this initial bed prepared well. Okay, so the summary, sand and clay are from different parents. Clay really has high CEC. It will compact. Sand does not compact. It doesn't hold as many nutrients. Organic matter has a very high CEC. It's food and glue. And structure is aggregates. Organic matter can improve in texture. So I made these in lighter, paler. Do you like that little? Less important. Okay, we're transitioning.
Okay, never mind.
No, go ahead.
No, I guess my question is on, like you open a bag of Daddy Pete's, supposedly great soil. And it looks like a bunch of little bark chips. Is that soil or is that bark chips?
Well, if it's bark chips, it's bark chips.
It looks like that. It says soil, but when you open it up, it doesn't look like soil.
Well, those bags, here it is. It's a sad story really, but they're not required to list everything that's in there, which is truly unfortunate. They're not required to actually do an analysis. And I've seen more problems than not with a lot of those materials. Now I will use Daddy Pete if I'm starting Daddy Pete's, if I'm starting a new garden or something. I don't have an objection to that, but I wouldn't use it repeatedly. And does it say it's garden soil? Does it say it's garden compost or garden conditioner or something else? There's very few rules on it. It's truly a buyer's beware thing. Okay, so the first thing we think about in taking care of our soils is a soil scientist never wants to see soil nude like this. We just don't want to see it like this. I can drive and see farmers' fields and it just, it's really hard for me to see it. A lot of them use cover crops. A lot of them are using no-till, but traditionally they've left them exposed. So we can cover them with plants. We can cover them with cover crops. We can use no-till. That means you're leaving all those residues on the surface and just planting right into them. I did my master's work on no-till, and actually now it's widespread accepted that you get higher production from no-till corn than you do from tilled corn. They fought it for many years, and there are reasons why a lot of places still don't use it, but it can be very productive, and it can be very productive in your home garden as well. The use of mulches. We're going to focus on the home gardens. We're not talking about agriculture here, but it applies on both scales and compost. So these are all ways that we can take care of our soil. Of course, we're going to include soil testing. So fun fact, did you know the Earth's soils contain more carbon, 3 times more that's in the atmosphere than is in the atmosphere, and 4 times more that's stored in all living plants and animals? Our soils are the reservoir for the Earth's carbon. And that's why there's all this talk about sequestering carbon, because the soil is a really great way to do it. And so when you till, let's see, no, the next one is not till. When you till, you're stirring up what's underneath, you're bringing carbon sources to the top, and they're burning off into the atmosphere. We don't want that. We want to keep our carbon in the soil. And so that's why all these techniques, mulching, no-till, cover crops, all these things are good because they're protecting that soil and the carbon that's stored within it. So cover crops, this is one slide on cover crops. And if you happen to love cover crops, you may get a call about them. I think in my career, I've probably gotten 2 or 3 people that ask about them. The main thing to remember, and then you can go research this, is we have summer cover crops and we have winter cover crops. So if they have a part of their garden or bare soil or whatever that they want to cover, you're going to find out, do you need something that grows in the heat, or do you need something that will grow over the winter? So I did my master's work on crimson clover. Of course, I love it. I think I'm going to go home today and throw some out. It's way too late, but I'm going to do it anyway. There's annual rye. You'll see this a lot. Burns out and dies in the heat. There's buckwheat, which is great, grows super fast. The insects love it. So there's a great resource from the Center for Environmental Farming Systems at NCSU. You can't read that clearly because I see it. But all you have to do is Google cover crops. CEFS, CEFS, and they have great publications, NC State, which ones to use when and all that. So cover crops are beautiful. Yeah, these bloom in the spring, so the early insects love them. No-till, I mentioned this already, it protects our soil structure. We've talked about structure. Maintains the worm tunnels. Don't underestimate worm tunnels. When we have big rains and there are structurally set up all these, aggregates, and then you have worm tunnels, the water will infiltrate remarkably better than if it's newly dug up. Like you think, oh, I'm going to dig up this garden, loosen it all up, and so the water will infiltrate. Well, actually, you have no macropores. So that water is just going to glob up in our clay, and it's going to have a harder time getting into the soil. So these worm tunnels are fantastic. It also keeps the microbial populations happy. When you turn up the soil, remember I said you're bringing that organic matter to the surface. The sun is heating it up. It's burning off carbon dioxide. Same thing happens with the microbes. You bring them up to the surface, they die. So we're not allowing our microbial population to really do their job when we keep stirring up our soil. So even in a raised bed, I think this is something to consider. It's a pretty unnatural environment anyway, but to give it a little effort to be as natural as it can be might be helpful. Improves water infiltration and reduces weed germination. Do you know it can take like a millionth of a second of light to hit some weed seeds, and they will know, oh, I'm going to germinate. That it triggers, I'm not kidding, it triggers germination in weed seeds, and some of them take like a fraction of a second. So the less that you overturn soil and expose those weed seeds to the sun, the fewer weeds you will have. So that, I promise you, is the truth. If you just let a garden be and work at it from the top, you will see fewer weeds over time. Okay, mulches. In our area, we have a lot of pine. Pine is our our mulch that is most sustainable for this region because we just have so much of it. You can get it shredded. It's a little bit crappy looking when it's shredded. You know, it doesn't shred up quite as nice as hardwood. Or you can get nuggets. And by the way, people will ask you about mulches. So familiarize yourself with the ones you brought if you're not familiar with them. They will say, which mulch should I use? And again, the answer is, I don't know, tell me about your gardening. So we have this hardwood mulch, we have pine straw, which is a harvested material, you know, beautiful, can be used, but we might want to use it in places where it really needs to be used and not in broader areas. We have a ton of leaf compost we can get from the city. You can get a truckload free. So yeah, we have some options.
What are the effects of the dyed hardwood?
I have read that they are non-toxic. I have also heard that some of them have herbicide in them. So again, buyer beware. I can't say that they're all. When I heard they had herbicide in it, it's like, are you? I almost used an expletive. It's like, you're selling this to people and they don't even know what they're putting out. He's like, well, most people like that. It's like, well, what if I'm growing something that, you know, I'm trying to seed a native, you know, flower garden or something. I don't want herbicide. And so ask. And I would advise your clients to ask if there's been anything applied to the mulch.
There's also a program, Chip Drop, where.
Yeah, she has a bag of, I was like, what's Chip Drop? Yeah. Chip Drop, where they just will bring this. This is not gonna have anything applied to it, I'm pretty sure.
And you don't know what tree is free.
Oh, it might I don't know if I put this in my favorite little vegetable garden, just because I'm so picky now. I've been hurt so many times by things I've put in there, just ignorantly.
You obviously don't get to pick what you're getting,
Right.
so
You don't
it's
get
at
to
the
pick.
mercy of what trees they
It's
shred.
really hard.
You know, the diseases that might possibly come from that, like, I don't know, armillaria or, yeah. I will say there can be a couple problems. Straw and hay can definitely bring in weeds. I got some vetch for years that I couldn't get rid of on some straw I brought in. And the leaves can, the ones you buy that leaf mulch from the city, can sometimes have weeds and bottle caps and whatnot in it, but yeah, it depends on what you're using it for. So here, I do think it's good. Here's one more aspect that people oftentimes don't talk about, but it's how quickly do they erode? And the chips are just going to flow easier. If they're on a hillside and you get a big rain, these things are just going to roll down the hill like a little marble. So in that case, the pine needles might be good. You know, leaf mulch, any one of these three at the top would be better than the nuggets. However, the nuggets are great if you have a flat pathway and you want it to last for a long time, look good, you know, low maintenance. So it really depends on what the need is. Pine straw is a harvested material, as I said, so we want to be mindful about how we use it. Using your local leaves is good. Okay, hardwood triple shredded mulch. I will say what Louise was saying, they can form a mat. I've seen this over and over. Instead of putting down 1 inch or 2 inch, you put down 4 inches, and before you know it, you have this hydrophobic mat, and even water won't penetrate. It dries out so hard that water just rolls right off it. So I love hardwood mulch. I have no problem with it. It's beautiful, but you have to know that it can mat, so don't use it too heavily. The second thing is if you have a white house and you put triple shredded mulch up against the house, you can get this artillery fungus.
Cars.
And what it is, do you all know about artillery fungus?
I know.
It's a little natural fungus that grows in more often than not in hardwood. Pine does not tend to happen, it doesn't tend to happen as much with pine. It's a little fungus that goes up like this and then pew, shoots off a black sticky
That you
liquid.
cannot get off.
You cannot get it off. You can barely paint over it, even if you paint your house.
Are you serious?
Well, it's hard. It's black and it's organic material, black, sticky, humic organic material, and it sticks. And I've had $1 million house cry. These people were crying because they had a terrible situation with
What does it
artillery
look like?
funds.
What does it look like on the house?
It looks like
Little black
dots.
speckles.
I have pictures, I'll show you. Little black dots. And
Why
it
you
just looks
think
like
so?
somebody.
They're
They're a quarter to an eighth of an inch little dots.
Very tiny.
that
And
cannot get off.
also they will shoot all over people's cars. So
They will.
So this, just something for you to know.
On the cars, you can scratch.
And once it's there, it's very hard to get rid of, just by the way. You can remove the mulch. I've had people put in stone to replace the mulch.
Yes.
But it's a hard fix. So I'll still use this, but I use it in areas where it's not gonna be a problem. So yeah, as I said, pine bark nuggets are pretty good. Okay. These are things we don't want to do with mulch. Honestly, I used to get calls like this, what's wrong with my tree? There's a lot of girdling there. The use of this landscape fabric, that's my neighbor. It's okay, but not if you really want to grow stuff under it. I mean, to me, it's useful. It's useful if you want to put it under a sidewalk or a pathway. But inevitably, plants will grow up through it. Then you can't pull it out because it's got plants in it. They can't breathe under there. I mean, to me, it's just a huge no-no. And of course, we don't keep applying mulch every year. I mean, when they say 1 to 3 inches a year, that doesn't mean forevermore. That means 1 to 3 inches when it needs it, not every year, but they like it to look fresh. So, okay, compost done. We are back to what is your style? This is where you're going to sit there and you're going to say, how active are you? Do you care about using your compost? What kind of materials do you have that you want to compost? What do you like doing? Do you like worms? Do you like shoveling super heavy stuff to your back? Kills you. When I was 30, I did. I was like, yeah, I'm going to move this one to this one and then this one to this one. I used to love that. I do not now. I'm like, nah, I just want to hold to drop this in. That's all I'm doing. That's what I use right now. So really, this is a personal preference. And we all want to encourage people to compost. They do have compost pickup now, like where you can put your branches and stuff in that bin. Does everybody here have that, or is that just in the city of Raleigh?
That bright green.
Yeah.
City of Raleigh.
It's just city of Raleigh. Yeah, and people outside the city probably just form a pile anyway and don't put it in their trash. But we have that, but we don't have a place to put our food yet. I was in Europe 25 years ago, and you could filled up your bucket and you just hung it out with your trash on trash day. Our food should not be going into the landfill. So if we can encourage people, we always want to be doing that. Okay, browns and greens. Do I need to spend time on this, or do people know this concept? You need to have something that's brownish, dryish, leaves, not necessarily sticks, but things that decay slowly. And then the things that have food in them, like your food, your grass, green grass. Browns would be hay. Greens would be vegetables from your garden that you're not eating. Coffee grounds. There's all kinds of things you can put in. So you have to have that mix. They need the browns to eat, and they need the greens for nutrition. And I'm sorry, Rhonda, she's actually in a beautiful hippie community out in California, so I don't feel too bad for her. She retired. Yeah. So I used to make compost. You can make absolutely gorgeous compost. I waited for, a couple weeks, turned this completely, then turned it again. I mean, it made extraordinary compost. So if you have somebody that really wants to make beautiful compost, help them out. Tell them how to do it. Get them the materials. We have beautiful compost materials, very detailed. Okay, so one thing that is important to know is finished compost has a high pH. So if you talk to people and they say, I haven't added anything except compost to my garden and I'm having this, the soil testing lab will say your vegetable garden should be a pH of 6.5. Your flowers should be 6.0, your lawn 6.0. If they have a higher pH than that and they haven't applied lime, it could well be from the compost. Compost has a natural finished pH of 7.3. And depending on what kind of thing it's composted from, if it's food or animal waste, it's going to be very high in phosphorus and potassium and zinc. So we'll talk about that a little bit more. In general, the compost that you can use that are not food related are like leaf compost, wood compost, no food, no animal. These are what you recommend when people have destroyed their gardens by adding too much of this. And that's pretty much every vegetable grower you know. We all have done this. We've applied beautiful, rich compost for years. We have completely jacked up our phosphorus levels and our zinc levels. And so when you see those soil reports, you can say, well, it might be good if you switch to something like this, where you'll get organic matter and the nutrients that are in there and the water, the glue, you'll get those kinds of things without the super high nutrient levels. So that's important. Okay. I want to finish this little section, so I'm sorry. I ordered some compost, covered it because I never leave anything unexposed or exposed with straw, and planted it, applied it to my tomatoes. And this is what happened. People, you will get this question if you sit on the phones anywhere. It's like, what happened to my tomatoes? Has anybody had this happen? Helen? You have? You know what it was from? Yeah. So this can happen if your neighbor sprays herbicides around your garden. 99% of the time, it's from compost that you've brought in that has it in it. And so when you talk to these people on the phone and they say, my tomatoes just don't look right, and they're tall and skinny, and say, well, is the top curling? Do the leaves feel thick and leathery and strappy? They call it strappy. They say, yeah. I mean, you can be pretty darn sure it's herbicide in their compost. Okay, so it can be in the straw or hay or manure or compost, and it can sit in there for up to 3 years. It's from these broadleaf weed herbicides that farmers use in their hay fields. And then the horses eat it, or they harvest the hay and the hay gets into compost. But this is the original use of it. It's banned for homeowners. Homeowners are not supposed to have these herbicides. Some do, whatever, but they're not supposed to. Most of the time it's going to come in on this. Here's a great article. You don't have to copy this down. Just Google Jeana Myers herbicide carryover. Excellent article. I mean, it happens. And certain years are worse than others. Certain years you'll get a bunch of them, like when that soil cube had that problem like 3 or 4 years ago. Oh my gosh, they were freaking out. Huge issue for them. They had no idea where it came in. They have changed their whole marketing thing. They have these different like vegetable gardening packets that I'm sure packets of compost that I'm sure they sell. Anyway, huge issue. There is no easy way to test for herbicides in a lab. People will want you to tell them that. There is no way. Herbicide chemistry is so complicated. That's what I did in my PhD work. It is so complicated. To even know how to analyze for something, you have to know what you're looking for, or you run hundreds and hundreds of dollars worth of tests to scan. So no, there is nothing available. There is no lab they can send it to. There isn't. Nilch, no. Confidently saying no. The only way you can do it is to get out 6 pots, fill 3 of them with some Miracle Grow potting soil or some kind of potting soil that you know is good. Mix in the other 3 pots half of your compost and half of the potting soil, and put some bean seeds in there and wait a couple weeks. And when these are peas, but you'll start to see something abnormal. You can put tomato seedlings in there, wait a couple weeks. You will see the abnormalities show up. And of course, if they show up in both pots, then you've got a different problem. If they show up only in the pot that has compost, half compost, then you know you have herbicide tainted in that compost. This is the only way. So just say, well, either don't use it or live with the results or do a bioassay. Those are your choices, people. Okay, so high zinc, I mentioned, look, my friend, oops, I almost said her name. She just had soil test done on her blueberries. Look at the zinc, 4,000. Zinc's supposed to be 25.
Oh my God.
And zinc at very high levels can stunt root growth. So this is a problem we'll talk about a little bit. So zinc can be very high in animal and food waste. Too much is toxic, especially at low pH, which we'll talk about in a moment. Test your compost before applying. And if soil levels are high, switch to one of those other woody composts. Don't use the animal food compost, which most of the bagged ones you buy are. Daddy pigs, you know, all this. So all organic matter isn't okay. Excuse me. You can do the bioassays. We can deal with weeds or shredded bark and compact and gets the artillery fungus, food waste. May have excessive nutrients. Excuse me. So where's our compost from? It's a complicated topic. It's a really complicated topic that we all want a simple answer, and it doesn't exist. Okay, summary, protect the soil, choose donor or apply, know your sources, soil test.